All right, welcome to another exciting Java class. In this class, we're going to review for the final. First thing I wanted to do was bring up the assignment from Blackboard, which we did last week. And just to review, I have committed to be here in this classroom at 2 o'clock on Monday. And you can demo your project and hand it in and then leave. To the students in the far corner of the room, I would ask that you please stop talking, because you can stay, but you have to be quiet, and it's a little distracting. So anyways, the bird's eye lowdown on this caper is it's first come, first served. Once you demo your final, you're done. There's no lecture, and then you can leave, and that's it. As far as coming early, if you come early and you're first, you'll be served first. And I'm going to be hanging out here until 3, I'm imagining that by 3:30 I'll be finished and I'll be off, and there's another meeting for me to go to, and so I'll go, unless someone thinks it's a hardship to come here at 2 or 3. Would anybody have any troubles with that? Yes? When can you come here?
I guess I can, but I'm just free other tests that day.
So how long should I be hanging out here waiting for you?
I guess I'll come as well.
Well, you tell me.
No, it's fine.
I mean, I could do it at 1 if you prefer.
No, that's actually 2 is fine.
I could take it, whenever you want,
No,
but
it's fine.
I mean, come in the morning if you want. Yes, sir.
405?
4 or 5? Is there a rationale for that? Oh, you have to work. Can you come in on your lunch break? I'll come early, and you could just be here at noon, and then hang out with me for 20 minutes or half an hour, and then head back.
I guess so.
Is 12 okay? Or 1 o'clock?
1 o'clock's better.
1 o'clock is good. Okay, I will make a note of it. 1 o'clock it is. And I'll be in my office.
Okay.
So 1 o'clock Monday. And if anybody wants to come around at 1 o'clock, then that's fine. And I'll be here until 3:30. So what we'll do is we can arrange for 1 o'clock hand-ins if that's better for you. The final and Alfredo. All right. You got it. 1 o'clock. Call me if you're not going to make it. Okay, good. Then we're going to demo the product, make sure it's submitted electronically to Blackboard. After that, you can leave. I'll be here at 2. Actually, I'm going to be here at 1, so that'll be fine. For your final, you are to implement a network 2-person Pong game that can work in real time. And so then obvious first question is, what is real time? If you find that RMI is too slow, we've already demonstrated how you can slow down the ball. So if the ball is moving slowly, that's okay. So if you find that things can't work properly unless you slow down the ball, that's okay. Slow down the ball. We'll still call it real time. But I still want to, get a feeling for what we can do with RMI with an interactive game. And we may find out in our exploration that RMI is just too slow and it can't keep up, and that's it. But, at some level, if we slow down the ball enough, we'll be able to accommodate it, and that'll get us a way to figure out how to deal with that quality of service. So real time is a relative thing. It's as much time as it takes. So get your game to work on 2 machines. So we've got plenty of machines here. Lots of machines. You can use RMI to communicate mouse events, but those mouse events could be encoded, as we have seen, in an efficient way. And an efficient way could mean like the Y coordinate of the paddle, maybe the clicking in order to start the ball, perhaps the score is needed in order to facilitate the communication. And one thing we noticed is that if we create a data structure with all of these things and pass it across the network, it's a reasonably efficient way to go. It can be a serialized data structure, a data structure that is, let's say, easily marshaled across the network, a data structure that we can use to update the state of our game. So you guys are, we've already demonstrated that, developed it, and distributed it as part of this so-called zip file. And hopefully you've all had a chance to give it a looky-loo by now. We notice that when the mouse is clicked, the game starts. The game has to communicate across the network. We needed a reset command to zero out the score. So for reset, we had a Boolean that would say, is reset true? And of course, if you hit the R key, and we saw how to handle the mouse event for the R key, we could set reset to true, and that reset function could be transmitted across the network as well, because primitive data types like Boolean are serializable. Primitive data types like the integer score or the y coordinate of the paddle are serializable. So from these basic things that we have, relatively strong variables, things like the ball can basically move similarly on both machines just from the single click. And we don't have to communicate ball position per se. When a ball encounters a paddle, it alters a score, and that can create an event that gets transmitted across the network. Score update. You can reuse or use any of the code that I've supplied in class, or you can write your own if you don't like what I've done. But here's the deal. The final cannot be handed in late because we're dealing with the end of the semester and the grades have to be handed in. I'm required to hand them in within 24 hours of the final, so late finals, that'll hurt you. So the final's due when it's due. If it doesn't work, my procedure on something like this is hand it in on time with a note that said, Professor, I had the following problems with the final, blah, 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 the score's not right, blah, 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 this didn't work, the other thing didn't work. Just own up to it so I don't have to sit there and struggle and try and make it work. But also I'm going to see a demo from you, so we'll see it right up front. If you had the idea that you wanted to hand it in using paper, that would be okay. I would accept paper for the final, and I would just take notes on it on the paper. So that would be okay for me. So far, so good. Any questions on what we've talked about so far? Is it clear? So the ground rules are you can ask me any question you want to now. But after this class is done, you're kind of on your own. This is the time when you can work a little independently and do the heavy lifting on the coding. So I'd like everyone here to have an equal opportunity to hear your question and hear my answer. So I think that opening the floor to questions about this final is a reasonably good idea, and I think that if you have any, presumably you've started your work on the final already, and you're not leaving it till the last minute because this final needs your focused attention. And if you do it with a deadline, you're not going to have good creative thought about this final. You need to give yourself time to work on this final, not the day before. I don't want to see, Professor, I didn't get a chance to work on the final because I started it Sunday afternoon and I know it's due Monday, because then it's hanging over your head like a dark cloud, a thing that you've been procrastinating for the last week and a half. So what can I do to try and help you guys along at this point? This could be a very short class. My lecture for today was to try and get you guys sort of up to speed with the final. Do you all feel like you're up to speed with the final? No. Okay. Well, that's good to know.
I know what you want us to do.
Yeah. Let's review some of the basic state variables. Yes.
Oh, I just had a question of so if I have the client and server on here, how am I getting it on the other computer? What do I have to do on the other computer
Okay, fair enough. So let's assume that we have, let's say, two computers in this classroom that communicate with one another. Presumably, I've had my computer communicate with you, and you've communicated with me, and we had a little chat program running. And one of the things I did was I got onto the local area network for the students. So right now, when I look at my Wi-Fi network, I see that I'm on Faxstaff Mobile. And I dare say that I cannot communicate with my students while I am on Faxstaff Mobile. So if you all are on guest or the student network, I would have to switch to either guest or the student network. And in that way, I would have to be able to, at least be on relatively the same, I'll say, logical network as you. So when that happens, what I can do to verify that things are communicating properly is I can try and ping your IP address. So for me to get to you, let's assume I would like to ping your computer right now. What network are you on? Is it guest? Student. Now I'm going to try and get onto the student network. Now I think I might be on the student network. I'm going to get to an I'm going to get to a command line prompt, CMD. And now what I'm going to do is I'm going to try and find out what my IP address is. Anybody know how to do that? IPconfig is correct. So then if IPconfig is run into more, that's a pipe, I should be able to see my IP address, and it's a version 4 address 10.47.480. So, Rebecca, can you ping me? Are you on a Mac? No. Okay. Or better yet, you could tell me your IP address and I'll try and ping your computer.
I did IPconfig and somewhere.
I'm pinging.
You are able to ping me? And what is the turnaround time? Or Brian, why don't you let me ping you? What's your IP address?
Do I have the turnaround time? Average is 81.339 milliseconds.
Okay, and now what's your IP address, please?
Mine is 10.247.
Uh-huh.
.4.48.
48?
Yep.
So it's looking like my average time to ping you is 77 milliseconds, which is, okay, I suppose. So now at this point, I can say that you and I are on the same local area network. And so now at this point, I should be able to run an RMI registry and have you rendezvous with it, or you can run an RMI registry and I could rendezvous with that. Either way. So if I were to run an RMI registry here, it would be at my local area network address of 10.247.480. And if you ran it where you're at, it would be at your local area address. From my point of view, it would be at 10.247.448. So the way I would say this is that we're both on the same exact local area network, because 10.247.4 is the prefix on both network addresses. And the difference is mine's an 80 and his is a 48. So other than that, it's very clear we're on the same local area network. And as a result, we should have no trouble opening up sockets and making connections to one another. So that's very key. So suppose, for example, I wanted to run a web server of my very own at location 10.247.480. Right? I could do that, and Brian could get to it. So that should be possible. Let's see what else we can do here. I should have an RMI data transmission capability. Let's see if we can. What should we do, do you think, to transmit some data to get some RMI happening here? I've got a server. Brian, do you have the same server on your machine?
I believe so.
It's very important, okay, to establish this connection properly, you need to have identical data structures on both machines with the same identical path names. That is to say, if I have Pong data in package graphics Pong, I cannot transmit that Pong data instance unless Brian has compiled Pong data into a class which resides in graphics.pong, the package. If he has any difference between his Pong data and my Pong data, it's very clear that we're going to get a class not found exception at runtime, because when he tries to cast my Pong data in the graphics Pong package into his Pong data in the Brian package, it will give me a class cast exception. And so there is I'll call it a synchronicity of class issue here. So it's very important, you know, if you think about it this way, a class is like a cookie cutter, and an instance is the cookie. Now, if I send you an instance of a cookie and it doesn't fit inside the cookie cutter, you get a class cast exception at runtime. So the instances have to be identical. You can't just, you know, we're dealing with here, and this is one of the things I like about Java, it's a strongly typed language. So that the data that is coming in has to be the data that was expected, or else you're going to know it right away. And that's kind of helpful from a debugging point of view, because you don't want things to just you know, accept raw data without question. You want the data to be correct. So it's very important, Brian, that before I start to send you Pong data, that you have Pong data in your graphics Pong package. And you don't, do you? Yeah, this is what you have to check first. It's sort of important. There are other things that you can do that may not involve strong data structures, which would allow you to transmit data across the network. Maybe building a little web server is one of them, and then you can just put in arbitrary strings and get some strings coming out. But at some level, if you don't have the same class as I have, this isn't going to work for you. Yes?
If we're on the same local area network, would it be easy for me to SSH into your IP address?
Oh yes, if I was running an SSH server, you could certainly come in.
Okay.
In fact, I even have an SSH client. But SSH is just a means of transmitting ASCII data from one place to another with security. There's no means of transporting instances of classes unless you serialize them into XML, as in Serial Object Access Protocol, or SOAP, or if you and then send them, or if you serialize them into some UU encoded format, like you would if you were attaching some sort of a attachment for an email. So without that kind of high-level encoding, RMI would not work. SOAP would, you know, be the exception. Does anybody else have the Pong data structure on their system? Has no one downloaded the code to compile it and run it? Oh, that's very bad. Now we can't really try these things. I wanted to try and see if I could get some communication running. How about, what do you guys have on your system? The zip file that I uploaded should have contained the entire Pong example from last week. So it's sort of important that somebody actually download it and try it. Would anyone like to try and download it and try it? I think it's so important that you get a little experience with this. I'll start my server just as though you were going to start your server on your system, or I would start, then you might start your client, or I could start my client on my system. So now we're waiting for remote Pong data. So if you had a client, let's see if we can make that work for us. The remote Pong data client would need to have an address that would not be localhost. Since I'm running my server on my own machine, I can use localhost. But because my machine has an IP address, which is here, I can also ping myself by my IP address. So here I am. This is the moral equivalent of pinging localhost. So ping localhost, and I should get the same answer. All less than a millisecond. But here you can see a fully qualified IP address, and here you don't see any name at all. But the results are the same. Average is 0 milliseconds, because we're going through the TCP/IP stack, but we're not going through the physical layer of the local area network. Yes, sir?
Can I see your Pong data structure?
Well, what I was going to do is make the client use the actual IP address here, and then when I get the Pong client running, I'll be able to register with the RMI registry and grab the data structure across the network using the RMI registry. So that's what you'd have to do from the client. So you'd put that IP address on your client in order to communicate with my machine. And that's how you'd run off the network. How you doing there, Kyle?
Ready.
You ready?
I just need to
You got to compile it first, right?
Well, do I need your IP address?
Well, it's right here on the screen. It's 10.247.4.80. Would you like to try and ping it before you run the RMI client? You're on a Mac. Are you on the student network or guest network? Student. Okay, great. So you should be able to ping me from where you're at.
Is it just ping?
Yeah, just bring up a terminal utility and try and ping 10.247.4.80. See if that works for you.
Yeah.
So that's all good. So now when you edit your remote Pong data client, you want to use, instead of localhost in the main, you want to use the Internet Protocol address for your RMI protocol. So it'll be RMI://10.247.4.80.
And which ones do I need to compile first?
Well, you're going to run the client. So you can, if you've got that whole thing in your program and it's compiling, all you have to do is recompile the remote Pong data client. How's that grab you? Are you still compiling?
Yeah.
Oh, okay. I can try and compile and run it myself and see if everything works properly.
Yeah, it's running.
Is it?
Yeah, I don't know if it's giving you the mouse.
Oh, well, I can check. I wasn't able to. He's waiting for remote Pong data. And you've got your client running, right?
Yeah.
So let's see, what does remote Pong client do? It's supposed to say test, send, receive. So you ran that. Did you get any output on your console? because it looks like there's a print statement here that should say something like getting data. So there should be something on your console. There's not. Is test send receive being invoked?
I see that. Yeah, I see that.
It is being invoked. All right, so then it should be doing a RH remote hand. RH, what's RH? RH is the remote Pong data. So you've looked up the port. RMI registry. He's using the RMI URL. The RMI URL should have been set. When you make an instance of remote Pong data client, it changes the location of the RMI URL. And what we can do here is we can print out, sout, Control J, enter, the RMI URL. So if you wanted to, you could print out the RMI URL and make sure it's correct.
Now something was popped up.
What did it say?
Getting data, and then it gave me an exception.
What was the exception?
Connection refused to host.
Connection refused. Is my server running? Maybe it isn't running. I may have stopped it. Let's try. I'll try and run the server again. What I'd like you to do is modify your client remote. Oh, you could run the server, and then I could modify my client, or you can run the client. It's all right. So what I did in here was I modified the client a little bit so that it would print out the RMI URL.
Yeah, it prints that out. For now it's waiting. I think it's just sitting here.
Yes, sir.
Sorry, what did you have to change? The client? I didn't see it.
I went to the remote Pong data client and I put a print statement in after the constructor set the location so that we could see the location on the console. You got that?
10.247.4.83.
Yeah, that's correct.
Remote Pong data.
Yeah, I'm going to print my IP address, pipe it into more, and sure enough, it's still ending in an 80. Thank goodness. Now I'm going to rerun my server. And now he says the exception's already in use, so it must be the case that there's another server running, and there it is. He's waiting for the remote Pong data on my side. So your client has to send me some remote Pong data.
It's just sitting here. My client.
So yeah, so it has your. So what we need to do now is modify your client so that it will.
Now it just pops up saying connection refused.
I just quit out of the server.
Yeah, so why would it? It's just sitting there doing nothing.
Right. So we need to get your client to send us some data. And then what my remote Pong data server is doing is it's saying waiting for remote Pong data. If you look at the remote Pong data implementation, right, what he's trying to do here is he's going to print out when you're sending data, and he's going to print out when you're getting data. But so far, all he's doing is he's sitting there waiting for data. So until you call get data or send data, nothing will happen. Right? So the server is just going to sit there. Right? It's not. All it's doing is it's passing data back and forth. So now let's look at the remote Pong data client. Might have been good for us to send some kind of data. So we've got the data. So it says look up. Here's the main. Now it says test, send, receive. So here's the data it's supposed to be sending on the client. And he's supposed to call get data and print it out locally. So he's supposed to be calling RH get data.
Yeah, I see that.
Huh?
I have that.
You have that. And did it print out the data?
I'm doing it.
You got getting data.
No, I didn't.
You never got getting data, so it never invoked test send receive. That's right in here. You never got this? Okay, so how about we put in a debugging statement, sout control J enter, about quote about to send data and get data. So we can put that print statement in there, and we'll put in another debugging print statement in your remote data client, and we'll write out something like this: test, send, receive, done. How's that? Now, if I run my own remote data implementation,
It doesn't execute those print statements.
well, the server's not running yet.
Okay.
So you're going to have to hold your suspense. So I want the remote data server to execute. Let me do the execution first on my local machine and make sure it all works properly. It seems like there's no good way to resize this console, but I can minimize it, I suppose. It says waiting for remote Pong data. So now what I'm going to do is I'm going to...
Which is different than mine.
I beg your pardon?
Your console's different than mine.
Oh.
Or if you grab above, like where it says the top of it works.
Do what now?
Once you have the console up.
I can't get the console up right now. I'm not sure how. For some reason, it's not allowing me to display the console, and I don't know why. So if we go to the remote Pong data client and run it on the local machine,
Click that run at the bottom. If you want it to work.
oh, click the run
Yeah.
button. Oh, you're right. So now he's giving me a problem. And his problem is he's not liking this IP address. So what I'll do is I'll try and run it on the local host, because he says it's not bound. So maybe I have another IP address, perhaps a Wi-Fi address or something, I don't know. I'll try it on local host. And now we'll get the server to run again. This time I'll get the remote Pong data server to run. And he says he's waiting. Now, Kyle, you say I can resize this somehow?
Yeah, put your mouse above where it says run.
Above where it says run? Here?
Lower.
Lower? Here? Up? Here?
It'd be like right on the border.
Ah, there we go. And so then now I need the remote Pong data client, which should be here. And we run that, see how that runs for us. Yep, that worked fine. So working with localhost seems to work. So let's see if the server is indeed located at the IP address that I had initially thought. So I went to Remote Pong Data Implementation. No, I guess it's Remote Pong Data Server. Here it is. And now it says here localhost. And it's rebinding to localhost. And my claim is that my IP address is here. So what I'm going to do is I'm going to rebind it to the IP address. Now let's see if I can bind it to my local IP address. So now he says he's waiting for it at this IP address. So I'm going to go to the Remote Pong Data Client, which is here. Remote Pong Data Client, and I'm going to try and bind it to the same IP address that the server is bound to. I hit run. And that worked as well. So now, Kyle, my next question is, when you run your Remote Pong Data Client using the same IP address as I'm using here, can you reach my machine and transmit data?
I don't have to change my server at all, right?
No, you shouldn't run your server at all. You should just run your client. Presumably your client has got the same package name as my client.
I ran it. It didn't do any of the print statements.
And it's not running and it's not producing output. And can you verify for me that your client is located in graphics.pong?
Yep.
And how about the other files, the zip, the Pong? It's all in there. Well, that's very educational. The only thing I can think of is someone is blocking the port. And that may, in fact, be the case. So what we can do is we can try it on a different port. Let's try an implementation using a server that has an IP address that's the same but uses a different RMI port. I think I can specify the port for the binding any way I like. Let's see now. When you want to rebind, maybe you can put the port right in here. Let's put it in port 80. And I'll start my server again on port 80. And I'll do this locally just to make sure things are correct. And I'll go to my client, and the RMI URL will have to change. And here he's using a registry port. I'm going to change the registry port. I'm going to change it so that it's 80. Because 80 is a non-common port for RMI, but it's a common port for web servers. It looks like I ran my server twice. That's going to give me an error. That you're not allowed to do. Let's find the original server, which is here, and get to the RMI Pong Data Client. Run that. Now I'm just running it locally, listening on port 80, and he wasn't able to get through on port 80 just now. Right? He says connection refused. So let's look at that RMI URL. See, now it doesn't have the port 80 on there. That's why the connection would be refused. Let's go back to the client and rerun it. Yeah, he's having a hard time. So there's something inherently wrong with the lookup using this URL. So let's think for a moment. It says here locate registry, get registry, lookup delegate. He's not happy with the idea of trying to get this client off of port 80. What could be the problem? RMI host implementation. RMI Pong data implementation. Where's the server? Remote data server. He's trying to get the registry. Let's see if this takes any parameters. It does not. It's rebinding. I'm going to take out the colon 80, and I'm going to go to the client, RMI Pong data client, which is here. I'm going to take out the 80. Take out the 80 in here. I don't think lookup delegate is being used in this one, right? Oh, maybe it is. See, the lookup delegate is doing a local lookup, and it needs to do a remote lookup. So this registry has to be able to. I have to get the registry on the foreign machine. That's your problem right there. It's looking for a local registry and not a remote registry. So get registry takes as its argument the host name. And what I think I can put in here is an IP address. So if I use that when I do a get registry, it should be hard-coded with an IP address for the server. And if I can get that to work, I think we can fix the bug. So let's do the remote Pong client server again. This time I'm going to run on the common port, which is port 1099 for RMI. This is a very good problem to have, actually, because it really gives you insight into issues. You know, the registries can be distributed across the network, but when you register something like a service, like a Pong data server, you really have to make sure you're on the right registry. So let's run the client. And that worked. Yeah, so I'm thinking that's what you got to do. Let's go to the remote Pong data client. Very good to have this problem in front of people, because now you guys can see what's really involved. When you want to get the registry, you want to get the registry on my server.
It worked.
And it did work.
Yeah, but
Cool.
like what data? So like what data is this sending? Shouldn't
It's
it be, like,
just send
constant
RMI Pong data. That's
so
all.
It's not actually like monitoring my mouse or anything.
No, we haven't hooked it up yet, but we could. We could. And so what I did was I had it send Pong data. What's it called now? I think it's called Pong data. Yeah, across the network. So in principle, when you ran your Pong data client, you ran test send receive. And when test send receive ran, it printed something like getting data on the console. Then it went to the remote server, got the data, printed the data, then it set the score, and then it set the data. So what that means to me is that the server is not just sending data, it's receiving data. And then it says here, sending data, and then it says got data. And every time it got the data, it printed it out. And then it sent data, and then it got data again. And then it's printing it out.
Does it only do that once? It's like for mine, it looks like it only does it once.
Yeah, well, my server may have done it more than once. I could have sent you some data back where, let's see now, the remote data server, I can modify it now, right? He says the remote data server, what shall we do? He's just waiting for a rebinding using a remote Pong data implementation. And the remote Pong data implementation contains a Pong data interface. So what can I do with this Pong data in order to update it appropriately? I say that the remote Pong data implementation should be a receiver of some Pong data so that it can proceed to communicate the data back out to the remote host. So somewhere we have this thing called RMI Pong. Now, does it have any Pong data in it? No. It's got a couple of things in it, but one thing it doesn't have is Pong data. So what I would do in a case like this is I would make sure that the Pong data is being sent from one program to the other, but I wouldn't do it until I made sure that the Pong data was incorporated into the game. So somehow Pong data has to be instantiated inside of the Pong game. The Pong data has to be set by the game and then sent to the receiver in order for the receiver to be able to update its state. So the Pong data is nothing more than a state, and the state needs to be communicated over the network. Does that sort of make sense? So my question then is, under what circumstances should I communicate Pong data across the network? What represents a change of state? Well, if the paddle moves, that's a change of state. If the score changes, that's a change of state. If someone hits reset, that's a change of state. As a matter of fact, anytime you set any Pong data, that's a change of state. And to maintain consistency across the network, anytime you set Pong data, you must transmit that Pong data to the receiver. What do you think of that?
Makes sense, but I don't know if I would know how to do that.
Well, first thing you need to know is, how do you transmit Pong data across the network? And we have a means of doing that. For example, here's this thing we're calling RMI Pong.
What is that?
Yes, sir.
What's the state?
The state of a system consists of the values of all of the elements that are needed to describe the system at any given point in time.
So, you think we'd be doing that in like an object? Or is there
Well, the Pong data contains all the state variables that we held as important for describing the state of our game. So our game server, in order to be consistent, needs to communicate the state of the game across the network. So, for example, if you had an autonomous land vehicle consisting of a car, you might have the position of the car, x and y, on the Cartesian coordinate plane, its orientation relative to the y-axis, call it theta, so they call that the pose, position and orientation. Plus, you might be interested in knowing its acceleration or deceleration, so that you could compute its velocity as a function of time. So at some level, those are all, its front wheel angle, for example, might be part of the state variable describing the car. So instead of just a series of x and y positions, you want to know something about the operational controls on the car. So here we are, operating our game, and we've decided that there are certain operational controls. A keyboard, right, because we have to hit R for reset. A mouse, because we want to click in order to be able to launch the ball, and also we want to be able to move in order to change the paddle position. So there are things that we like to listen to, right? And so what I would say is, in the case of Pong data, we have an observable element which needs to be communicated to the client, who becomes an observer of the Pong data. So it's an observer-observable relationship. That's the way I see it. And what we have here is something called an observable Pong state. And the observable Pong state looks like it has a whole series of different points. And I think it would be really good for us to know if the observable Pong state has centralized all of the state variables that we care about. So, for example, if the racket is changing in its location, it would be really swell to know when state variables are changing. And it looks to me like the observable Pong state can print out itself. Let's see what happens if we run the main. It's using reflection to print out all the state variables for the observable Pong state, but we've come up with something a little more efficient than the observable Pong state, right? And that is what it seems to print. That's very nice. Now, suppose you took the observable Pong state, and every time it changed, we printed out its state. Does it have a? It has an update thing, and then it says print reflection. So we've overridden the observer of the observable Pong state. Suppose we went into notify observers. And every time we went to notify the observers, we printed out the state variable. And the state variable consists only of this. So if someone is calling change and notify, we'd like to know it. And I'd like to know how often it's being called. Is it being called when the ball misses the paddle? Is it being called when the ball when the paddle moves? Is it being called when the score changes? I need to know that. If it's not being called correctly or often enough, then this is not any good to me, and I'll have to modify it or debug it. So what I'd like to do is just get an idea as to what observable Pong state is being is when it's being called. So I'm going to run the RMI Pong program. And let's see if we get some kind of console output that tells us about the observable Pong state. And it's certainly not giving us a stream of different values here. Let's start the game. And now let's miss. So observable Pong state is not being updated appropriately. So that's not good for me, right? So if I look at the observable Pong state again, I have to wonder, gee, you know, what good is it if it doesn't get updated sufficiently? And what can I do to get it to be updated? And when would it be updated? Here's the Pong state. It looks like it's being set. After all of the setting is done, I should think it needs to be updated, so I need to set changed, but it doesn't seem to want to do that. How about update? Here's an update. Here's has changed. Here's notify observers. That sounds like a good one, right? Let's see if notify observers does anything for me. So if I go into the Pong state and do a notify observers, this is in the observable class, I want to see the Pong state. So where's the observable Pong state? Somewhere in here, right? Observable Pong state. We click on PS, click there, click in here, click there. Here's the observable Pong state. What's going to cause, I want change and notify to be done. I think I'll make that public. And I'll just call change and notify whenever I feel like it's appropriate. Apparently set racket point does it automatically. Set enemy point does it automatically. Set death does not. Probably should. Set player score probably should as well. I think if it dies, that should cause a notification. If somebody's setting the score, I think that should cause a notification. You can kind of see where I'm going here. There are a few different things that you can do to a state variable that should cause notification. If somebody is setting the ball speed, I think that should cause a notification. What else? So I got a bunch of things in here. Looks like they're all going to set notifications. Let's run it again. I'm real interested in seeing the paddle move, but I don't see paddle motion in any of this. I got ballpoint. This is not, see, the paddle moving is not being updated here, so I don't have a proper sense of Pong state. Let's see if point scored. Yep, so I got some output here. That was pretty good, and I got the points, but it's not giving me an update on what I would call the actual paddle position. So I'd like paddles to be communicated as well. So maybe it makes sense to start with our own thing. We could call it Pong data and put the Pong data in here, set it, and then send it. What else could do it? I mean, here's an interesting point, right? Here he's doing get racket point, but he's not setting anything. So that's the kind of information I really wanted to transmit across the network. Whenever the mouse moved, that's the information I wanted to use to change the Pong data. So as far as I'm concerned, the observable Pong state isn't really particularly useful to me. It's not the data I want. Right? I wanted different data. So I'm going to take this print statement out of here, and I'm going to create my own introduction of the Pong data into the system. So if you said to me, well, RMI Pong is different from regular Pong because it has Pong data, then I'd say, great, let's get the Pong data. And whenever the Pong data is updated, we'll have to transmit it across the network. Right? So that's a key element. What else can we say about Pong data? Is there a good print statement for Pong data? Looks like there is, right? Yes, sir.
Can I see your constructor really quick? I'm sorry.
For what?
Pong data.
Yeah, the constructor is null, isn't it? There's no constructor.
Oh.
We can put one in. We can make a public constructor. There. How's that?
If I don't have a constructor, when I define my Pong data object in another class, I don't need to pass anything?
No, but presumably the Pong data gets constructed by default the same way on both sides, the client and the server.
Mm-hmm.
So what I would do is I would communicate the Pong data from one side to the other while playing Pong. A thought occurred to me by putting in this constructor just now. I probably broke serialization between myself and Kyle because I've added a method. Yeah.
When you put this y equals y, is that so you don't have to make them static?
Yeah, there are no static methods and no static. Pong data is completely dynamic.
Would you break anything if you made it static?
You'd break serialization unless you did it on both sides.
If you did on both sides of it.
If you did it on both sides, it would be fine. But
I never really understood the difference of like the pros and cons of making it all static or dynamic.
well, if it's static, there wouldn't be much point in well, if you made it static final, it would be a constant,
Oh, yeah.
and then you wouldn't need to pass it across the network. It would be constant. If you made it static and then changed it and then passed it across the network, the static variable would change, and it would change for all instances of the Pong data if you had multiple instances on the same Java virtual machine, because they would share memory.
I see.
So you're sharing memory across instances, but not across machines. It's very different when you use RMI. So the way I would say it is this. Your Pong data, it probably needs to be updated when you are changing your mouse position. So I would say let's make a new instance of Pong data, put it into the RMI Pong, then take the Pong data and figure out what it is we want to do when we move the racket. And I figure the racket is going to move whenever you get a mouse moved, right? So there should be like a mouse moved event over in here. And I'm thinking Pong data dot set y to be I'm using this point here called y, and just for a good time I could print out the Pong data, sout control J enter PD. So knowing now as I do that Pong data is being set properly, I should expect that anytime I move the mouse I should see the Pong data actually get altered and printed on the screen. And instead of sending it to the console, I probably want to send it to the client. So here's all this Pong data coming in. Should it be integrated with the send client thing now, or should we do some more stuff like change Pong data when I click. Because here, when I click, is restarted, it didn't output true. Or is clicked, didn't output true. So what would I do to make it so that Pong data was set properly when things are clicked? Right, here's mouse clicked. Why not do something like this? Pong data dot, I think there must be something called set clicked, right? So then when it's clicked, I can set it to be equal to true. And now when I click on the mouse, Pong data will print out. Does that sound right? Everybody good with this? You see where I'm going, right? I'm taking the important things, like when I click, when I control the game, and I want to pass them across the network. But before I do that, I want to make sure the data structure is set properly. So here's the Y position being changed, and Y is on the left versus the Y on the right. I'll do a clicked, and click is now true because it was clicked.
Shouldn't it change it back to false?
At what point should it do that?
Once you start moving the mouse again. Perhaps.
Well, if you wanted to restart the game with an R, I'm not sure. Okay, I don't know the answer to that question. There was supposed to be a restart, right? And we were going to listen to the mouse. No, the keyboard. Right. So there was going to be a key event listener involved with this, and what we don't have here is a key listener. And what I recall doing is creating an example with a key listener. So I'm pretty sure that this applet has to be a key listener. So I'm going to, is it key event listener? I forget now. Key event listener? No, key listener? You tell me. Key listener. It's got to be a key listener. So now as a key listener, it has to implement certain methods. Key typed, key pressed, key released. So now we've got this sort of key typed event. And when the key is typed, I can print the event. S out, Control J, Enter, and I'll just print the event for my own edification to see what it prints out. And I imagine I'm going to be real interested in the event where somebody prints like an R. Somebody types an R. So I'll hit an R. Doesn't seem to be doing much. Did I forget to add the key listener to the... yeah, I have to add it. Right, so in the constructor for the RMI Pong instance, I have to add a key listener. It'll be right in the same place where we call add mouse listener. So then we'll have to add key listener this. So now I'm connected to myself. So key events from the applet will flow into the applet body and come out in key pressed, key released, and key typed. I'm not seeing key events here, so it must be the case that the key events are getting their focus into somewhere else. Let's see where that might be. The mouse motion listener is here. I'm going to go back to the example where we had the key listener and I think it was in book examples, mouse input. Does anybody remember where the key listener was at? Where is it at? 22? I'm not seeing it here.
It was in our mouse example.
It's in the mouse example. So I see a mouse motion listener. I don't see a key listener here. Here's a closable frame. Still not seeing a key listener here.
It's in mouse example.
Mouse example? Where is the mouse example?
It was on Blackboard.
Okay, so if I do a search, I can find it in the path. Mouse example. Doesn't seem to have made it into my code.
Does case matter?
It could do. Find in path. It says case sensitive. Let's turn that off. So here is Pong mouse example. So it's in the Pong package. That's why I had trouble finding it. So apparently, this is associated with the overriding frame. So the keyboard frame is what got key typed in there. And if you ran it here, yeah, you got the reset. So would it make sense to put RMI Pong instead of in an applet inside of a panel, and then take the panel and put it inside of a frame? Why should it be an applet? Any ideas? Is there any advantage to having this as an applet at this point? What if I make this a panel, J panel? Can I make a main method or a main window and stick it in there? Right? There should be like a main in here somewhere. There's no main, so we can make our own main, right? And put RMI Pong, the J panel, inside of it, and then manage our own applet. So I'll do public static void main, and then I'll put in a closable J frame. And then what I'll do is I'll get my little container. So I'll get the content pane, which will return a container. And then what I'll do is I'll get my applet panel, RMI Pong, RP, equals new RMI Pong. Then what I'll do is I'll take the RMI Pong and I'll add it using border layout to the container. So I think I need to do something like this: c.add rp. And now if I add it using border layout, maybe I should set the layout. So let's set the layout first. We'll do cf.setLayout to be new border layout. And then when we add the panel, we'll add it to the center. Border layout dot center. And now I think maybe we can set the size. What do you think's a good size for this? The applet must have given us some guidance on this, right? Oh, maybe not. We'll just make up a number then. I don't think it's much more than 300 by 300. And then we'll set visibility to be true. Then we'll call init. No? Oh, it's rp.init. And then we'll call rp.start. And I think that's all you need to run an applet, but I could be wrong about that. I don't convert applets into applications every day. Okay, so the init was no good. Oh, I didn't set the visibility. I just wrote is visible. I have to do set visible true. That's not bad. A little error at first, but it looks like it's starting to work. How about that? Now let's run it again and see what the problem was, because I don't like that little exception that got thrown out before it started to run. So what was the story here? Oh, the paint method was getting a null because the off-screen was null. Let's take a check in here. If off-screen is null, then return. That'll save me from the initial error. And then we'll run it again. I think that'll save us from having to deal with the error at the beginning. Yep. Pretty cool, right? Turn an applet into an application. And now I can play the game. Ooh, how fun. Whee. So what do you think of that? Applets into applications. Want a review on what happened here? An applet is nothing more than a panel that resides typically inside of a browser's frame. And normally, if we want to run the applet as an application, what we do is we create our own frame in order to host the applet panel. So what I did was I pretended that I was a browser, and I gave the applet all the services that it would expect from a browser. I gave it a frame. I gave it a layout. I initialized the applet because it expects init to be invoked by browsers. And then I started the applet thread by calling start, because applets expect that from browsers. The only other thing I did was I set the size of my frame. Browsers always have a size. And I set the visibility to be true. And I had to do those before I called init. The order in which you do it for an applet is really quite important, because you dare not try and have the applet paint while it's invisible, because that will give you an exception at runtime. The graphics context will not have been instantiated. So converting an applet into an application is not particularly difficult when you know how, but then again, as I'm fond of saying, everything is easy when you know how. But now you've seen it, and now you know how to do it, and it's not particularly hard, right? It's just a couple lines of code, and there it is. Applets become applications. I don't know if you've ever done that before, and it's certainly a sticky point in Java because you don't see a lot of applets anymore, but they're still out there. And if you come across one, this is how you host it. IntelliJ does this for you, by the way. When you mouse right on an applet and you start to run it, it creates its own frame and it starts to host it for you. But here now you've got an opportunity to do something for yourself that you hadn't done before. For example, now I can add a mouse listener to the to this frame. So I can, if I know that RMI Pong is also a keyboard listener, I can go to the closable frame and add the key listener RP. So now RP is a processor of key events not just from the applet panel, but also from the frame. So if the frame starts to get focus on the key on the keyboard, that those events should flow into the RMI Pong instance. What do you think of that? You can kind of see there's a method behind my madness here, right? Because I really wanted keyboard events like these to come through, and now they're coming through. So if I type R, you can see keychar R is coming in because the frame has got the focus. I added the remote Pong as a key listener. So I said cf.add key listener remote Pong because I knew that the frame which was hosting the applet had been constructed for me by IntelliJ. As a result, I didn't have control over that frame. So I was forced to create my own frame, and then I could add the remote Pong key listener to that frame so that key events would flow into the applet. Otherwise, the applet was ignoring all key events because it wasn't getting key focus. It was getting, the only thing that had key focus was the frame created by IntelliJ. Is it making sense? I'm not hearing a yes. Yes? Good? Brian?
I'm using Ruby.
You're doing what now?
I'm gonna do Ruby.
You're doing Ruby?
Yeah. Well, not
My hero. You're going to teach me Ruby then after that.
Yeah.
Good. So then, where were we? Ah, yes. So if you looked at your mouse example, here was key typed. And if you looked at how key type was implemented, it said, look, if the keychar is reset, it prints out a reset. It sets restarted true, sets click to false, and otherwise prints out an else statement. I can borrow the implementation of the key typed event right in here. I'll just copy it because this is exactly what I expected to have to do inside of my Pong, my RMI Pong example. So when I go to my RMI Pong, I would expect to see a key typed event, and sure enough, here it is. I can paste in the body for my example, and it intercepts the R key, prints out the reset on the console, sets the Pong data to set restarted as true, and sets clicked to false. So now when I run RMI Pong,
The same for the mouse too. Is that reset without?
yeah, well, I think the mouse is not, didn't have a, mouse focus was already obtained by RMI Pong, but what wasn't obtained was the keyboard focus. So what I'll do here is I'll move things along. I'll hit the R key, and sure enough, it prints out reset. And is clicked is still false. But if I hit click and then hit reset, you can see is clicked is false. If I hit clicked is clicked is true, is clicked is true. I hit reset, is clicked becomes false. What do you think of that? Cool, right? It's like we're game programmers now. How fun. Very fun. So now I've connected my Pong data to my keyboard. I connected my Pong data to my mouse. There's a thingy about scoring, right? When we can connect it to the scoring. Shall we do that as well? Somewhere in here he's got a score. I think it must be, it's probably in the Pong state where he does set score. So let's do, where is he going to set the score? Oh, when you hit reset, should the score be 0? I'm thinking that's right. Probably pd dot set score set score SCORE to 0. How's that? When else is he going to be setting the score? There's a thing about missing, right? Well, I'm not sure where it is. Here's drawstring.
It isn't actually updating the score.
Enemy score. Get enemy score. Get enemy score. How about ps.set enemy score, set player score? Here it is. Here he sets the enemy score. No, that's enemy point. I want to do a search. Set enemy score. Huh. How about this? Whenever there's a miss, he goes to Pong data and says set enemy, set score.
Shouldn't we have 2 scores in our...
Yeah, I wonder if that isn't true. Shall we have an enemy score and a player score? I don't know. I'll just set the score right now to ps.getEnemyScore. And what we'll do is we'll print the data just for good time, just so we can see the score change. So I'm thinking that should work if we miss. So maybe it works if I win.
We need 2 separate scores. To make sense.
Did it just print anything?
It only does it when you lose.
Did it print any? I don't see it printing any. Oh, here's score. It says score equals 1. So the score is in there, but it only happens when I lose. And here score is 0. So score is changing. Yeah, you might want to put in an enemy score and a friendly score. That might make sense. So if Pong data has 2 scores, then you better give them 2 names. How do I know which is the enemy and which is the player?
My score.
My score? Which score is my score? Is that the client or the server? Yeah, maybe you need a score for player 1 and score for player 2, but I still don't know which one is player 1 and player 2. Maybe I could have, some way to figure that out. Client player or server player, something like this. Right now I've just got a score. Huh, that's a good question. I'll let you guys ponder that one. I would rather focus on more or less deeper problems like communication. But if you want, we can do the detail on what to call the score. Should it be score and score 1, just like we have y and y1? Would that make sense? Okay. Oops. Copy, paste, paste, so that's score 1. And then here's get score and set score. Copy, paste, enter, paste. So now we'll have get score 1 and set score 1. And this will be score 1 and score 1, and that'll be score 1.
Why the second score?
Well, because Kyle says you've got 2 players, and so you should, if you get an enemy's player state and a player state, then you'll have set score and set score 1.
I would imagine that Pong data, they each have their own Pong data, they each have their own object that keep tracks of their score.
Yeah, but you're communicating this object across the net. So what is it you
Should
want
the
to?
server know the scores of both of them?
You can do it any one of 2 ways, maybe more. One way would be to create an objective server that does nothing but keep track of the state and then updates all the interested parties. The other way is to do a peer-to-peer relationship where when one person sees a score change, the other person gets the update. And when the other person sees a score change, the other person gets the update. So let's call one player 1 and the other player 0, I guess. And if player 0 has a change in Pong data, it communicates it to player 1. And when player 1 has a change in Pong data, it communicates it to player 0. So they need 2 separate scores because they're represented in 2 separate numbers that are drawn on the screen. So when scores change, they have to be communicated. When paddles move, they have to be communicated. So lots of back and forth communication here between the Pong data, as I see it. Don't you think?
But the server has its own Pong data object, right? Because you're player 1, for example.
Well, I'm assuming that the server is running the registry, and it's going to have an instance of Pong data, which is going to have to be separate from the instance in player 1. So when player 0, which also happens to be running the server, changes its Pong data, it has to transmit it back to player 1. When player 1 gets a copy of the Pong data, it must replace its copy, its local copy, with the new updated copy with the new scores and the new paddle positions. Then when its paddle changes, or when its score changes, it has to take that copy of the Pong data and pass it back to player 0.
Okay. Yeah, I see. There's 2 ways to do it.
Now you could say they don't each get their own copy. You could say only player 0 has a copy of the data, and then all you're doing is you're updating the data on player 0. But that doesn't make sense a whole lot unless you plan on, well, you could do that. You could always keep sending data to player 0.
Maybe I'll just name it enemy score.
Well, how do I know which is the enemy? I got 0 and 1 right now.
No, but they each have their own 0 and 1. One is always the other, right?
Oh, I don't know about that.
Oh.
That's confusing.
Right, yeah.
I like to think of the server has player 0, the client has player 1. Do you guys need to go now?
Yeah, roughly.
All right, so if you want, we can call it quits for now. You guys have a little bit more insight than you had from before. What I'd like to do to wrap things up is to give you an update of the code that we did today. I would like to zip it and upload it to Blackboard and give you all a chance to have at it if you want it. So we'll make a new zip file now. Maybe we'll call it pong2.zip. Upload it to the finals so that you can have at it. And best of luck to you. This will be due on Monday. So we'll end the class a little bit early since some people have to go.
Can we ask questions if we want to?
And you can hang about and ask questions if you want. I'll hold off on this. Let's take a little break first. So I think some people are leaving. So I'm going to